spiral-bound 2005 National Electrical Code book is sold by both Mike Holt and the National Fire Protection Association. The National Fire Protection Association offers the 2005 National Electrical Code spiral-bound loose-leaf edition through their website. Mike Holt also provides the spiral-bound version. When seeking the CD version of the National Electrical Code Handbook and the National Electrical Code itself, Mike Holt offers the CD version of the 2005 National Electrical Code Handbook. The CD version of the 2005 National Electrical Code is not available from the National Fire Protection Association. Therefore, if interested in the CD format, it is available through Mike Holt's resources. Accessing the correct and updated version of the National Electrical Code is vital for electrical work. It is the standard for safe electrical installation. The National Electrical Code is updated every 3 years. These updates incorporate new technologies, safety practices, and address emerging issues within the electrical industry. Knowing where to find these resources, whether the spiral-bound book or the CD version, is the first step in ensuring compliance with the latest regulations. Firstly, consider the format that best suits work style and needs. A spiral-bound book is excellent for field use and quick reference. A CD version allows for keyword searching and digital access. Secondly, remember to verify that the resources are up to date. Using outdated information can lead to code violations and unsafe electrical installations. Thirdly, always consult the official National Electrical Code document for precise regulations. Other resources, such as handbooks and training materials, are valuable supplements but should not replace the primary code document. Fourthly, understand the scope of the National Electrical Code. It covers electrical installations in buildings and other structures. It does not cover specific equipment or appliances, which are typically addressed by other standards. Fifthly, familiarize yourself with the structure of the National Electrical Code. It is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Sixthly, stay informed about amendments and interpretations of the National Electrical Code. Local jurisdictions may adopt amendments to the National Electrical Code. Interpretations of the code are provided by the National Fire Protection Association and other organizations. Seventhly, consider taking courses or workshops on the National Electrical Code. These training programs can help understand the code's requirements and apply them correctly in the field. Eighthly, use the National Electrical Code as a guide, not a rigid set of rules. Apply electrical knowledge and sound judgment when implementing the code's provisions. Ninthly, remember that safety is the primary goal of the National Electrical Code. Adhering to the code's requirements helps protect people and property from electrical hazards. Tenthly, continuously update electrical knowledge and skills. The electrical field is constantly evolving, and staying current with the latest technologies and practices is essential. When working with electrical systems, it's important to understand concepts such as voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge through a circuit, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. Ohm's law states that the voltage across a resistor is equal to the current flowing through it multiplied by its resistance. This fundamental law is expressed as volts equals amps times ohms. Electrical circuits can be either series or parallel. In a series circuit, the components are connected end to end, so the current is the same through all components. In a parallel circuit, the components are connected side by side, so the voltage is the same across all components. Electrical safety is paramount when working with electrical systems. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. Grounding is another critical aspect of electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Grounding systems must be properly installed and maintained to ensure their effectiveness. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a certain value. Fuses are one-time devices that melt and open the circuit when the current exceeds a certain value. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. An arc flash is a release of energy in the form of heat, light, and pressure. Arc flashes can cause severe burns, injuries, and even death. Arc flash protection requires the use of personal protective equipment such as arc-rated clothing and face shields. Electrical wiring methods are governed by the National Electrical Code. The National Electrical Code specifies the types of wiring that are permitted for different applications. It also specifies the installation requirements for wiring, such as conduit fill and support spacing. Conduit is a protective enclosure for electrical wiring. Conduit can be made of metal or plastic. Conduit fill refers to the amount of space inside the conduit that is occupied by wires. The National Electrical Code specifies the maximum conduit fill to prevent overheating of the wires. Wiring devices, such as switches and receptacles, must be properly installed and grounded. Switches are used to control the flow of current in a circuit. Receptacles are used to provide a connection point for electrical equipment. All wiring devices must be rated for the voltage and current of the circuit. Electrical panels are used to distribute electrical power to different circuits in a building. Electrical panels contain circuit breakers or fuses that protect the circuits from overloads and short circuits. Electrical panels must be properly grounded and labeled. Transformers are used to change the voltage of electrical power. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformers are used in a variety of applications such as power distribution and electronic equipment. Motors are used to convert electrical energy into mechanical energy. Motors are used in a variety of applications such as pumps, fans, and compressors. Motors must be properly sized and protected from overloads. Lighting is an important aspect of electrical design. Lighting can be used to provide illumination for work, safety, and aesthetics. Lighting systems must be designed to meet the requirements of the National Electrical Code and other applicable standards. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Renewable energy systems require special wiring and equipment. The National Electrical Code contains specific requirements for renewable energy systems. Electrical inspections are performed to ensure that electrical installations comply with the National Electrical Code and other applicable standards. Electrical inspections are typically performed by local government agencies or qualified third-party inspectors. Staying up to date with the electrical codes and standards is essential for all electrical professionals. The National Electrical Code is updated every 3 years, and it is important to be aware of the latest changes. There are many resources available to help electrical professionals stay up to date, such as training courses, publications, and websites. Some common electrical calculations include calculating voltage drop, conductor sizing, and conduit fill. Voltage drop is the decrease in voltage along a conductor due to its resistance. Conductor sizing is the process of selecting the appropriate size of conductor for a given application. Conduit fill is the amount of space inside a conduit that is occupied by wires. Understanding these calculations is essential for designing safe and efficient electrical systems. Electrical troubleshooting involves identifying and resolving problems in electrical systems. Troubleshooting requires a systematic approach and a good understanding of electrical principles. Common troubleshooting techniques include visual inspection, voltage testing, and continuity testing. Electrical safety audits are performed to identify potential hazards in electrical systems. Electrical safety audits can help prevent accidents and injuries. Audits should be performed by qualified professionals. Electrical preventative maintenance involves performing regular maintenance on electrical equipment to prevent failures. Preventative maintenance can help extend the life of electrical equipment and improve its reliability. Common preventative maintenance tasks include inspecting connections, cleaning equipment, and testing insulation resistance. The 2005 National Electrical Code, like subsequent editions, includes articles addressing specific equipment and systems. For example, Article 250 covers grounding and bonding, which are vital for electrical safety. Article 300 covers wiring methods, outlining the requirements for different types of wiring and their installation. Article 400 covers flexible cords and cables, detailing their approved uses and limitations. Article 430 focuses on motors, motor circuits, and controllers, providing guidance on motor protection and control. Article 440 addresses air conditioning and refrigeration equipment, covering the specific electrical requirements for these systems. Article 500 and subsequent articles address hazardous locations, classifying different types of hazardous environments and specifying the appropriate wiring methods and equipment. Article 600 covers electric signs and outline lighting, detailing the requirements for sign installations. Article 625 focuses on electric vehicle charging systems, which have become increasingly relevant in recent years. Article 680 addresses swimming pools, fountains, and similar installations, providing specific safety requirements for these wet environments. Always refer to the specific articles within the National Electrical Code for detailed guidance on each of these topics. Changes in the National Electrical Code from one edition to the next reflect advancements in technology, changes in industry practices, and a continued emphasis on electrical safety. The National Fire Protection Association is responsible for developing and publishing the National Electrical Code. The process of updating the National Electrical Code involves input from various stakeholders, including electrical contractors, engineers, inspectors, manufacturers, and consumers. The National Electrical Code is adopted by many jurisdictions throughout the United States and is often used as a basis for electrical codes in other countries. Continuing education is essential for electrical professionals to stay current with the National Electrical Code and best practices. Certifications, such as those offered by the National Institute for Certification in Engineering Technologies, can demonstrate electrical knowledge and competency. Being knowledgeable about the National Electrical Code and adhering to its requirements is crucial for ensuring electrical safety and preventing electrical hazards.